Hello and welcome to episode 95 of Linux Dev Time. I'm Joe.
I'm Amalith.
I'm Kevin.
I'm Andy.
I'm Drew.
Good to talk to you all again, and welcome to the show, Drew.
Thank you.
So back in November 2023, you posted on your blog, "Can I be on your podcast?" So we emailed you and said, "Would you like to be on ours?" And here you are. And this is to promote your programming language, Hare.
That's right. I posted on this blog that I would love to visit some podcasts like yours, particularly free software related, Linux related stuff like this. So I'm very excited to be here and share this project.
So what is Hare then?
Hare is a systems programming language. It's designed to be small and simple and reliable. It's kind of the C replacement domain language, which is closest to C is usually how I would describe it.
I'm sure you get this question a ton of times, but with other languages out there like Zig or even newer ones like Odin and Veil and Rust and things like that, where do you see Hare fitting into this space?
That's a good question. I wouldn't have made Hare if I didn't think that there was a need for it. I tried to learn Rust a while ago, and I see it has its place, but I see it more coming from a lineage which is culturally closer to C++ than C. I also tried Zig, and I thought it was very promising, but in the end, I thought that there was a number of design choices that made it not exactly what I was looking for. But essentially, the thing that sets Hare apart is that it should be similar in capability to a lot of what these things are doing. You can do low-level systems tasks, network programming, operating systems, kernels, bootloaders even, in Hare. But the design of the language and the implementation is such that the entire implementation should be comprehensible by a single person. And I think that that's something that none of those other languages have really achieved.
Hare is also already bootstrapped in itself, right? Hare is already written in Hare?
No, and actually, it's not written in Hare yet. We have a bootstrapping process that we've started building, but it's not complete. The main Hare compiler is written in C, in POSIX compatible C11, so it should be highly portable. And we are working on some of the tools that will become a hosted Hare compiler, but we haven't completed the bootstrap yet.
Okay, that makes sense. One of the other things, too, I saw when looking into Hare was that you use QBE for your backend.
That's right.
Instead of something like LLVM or you name it. How has that worked out for you? And also, why was that decision made?
That's actually a really important choice that we made, is to use Cube rather than LLVM or something similar. Essentially, it plays into that detail I mentioned earlier, which is that we should be as small and simple as possible while still solving the problem, and ideally being comprehensible by a single person, the whole toolchain. And there's no way that LLVM is comprehensible by a single person. Not a chance. Whereas Cube gets performance, which in my opinion is competitive for a lot of use cases. Not for every use case, but for many use cases, it can get like 70 to 80% of the performance of LLVM. But it does it in something like 15,000 lines of code, whereas LLVM is closer to 15 million lines of code. And so I thought that that was a kind of natural choice for us, given the goals of Hare to be simple and comprehensible.
Okay, that makes perfect sense. And then did that also play into like some of the compile times or even optimizations? I'm sure that Cube has a different profile than some of the other backends. Is there much difference? I've never used it personally before.
Well, we don't have an LLVM backend to compare apples to apples with, but I can say that the compile times are definitely significantly better just because Cube is not doing nearly as much stuff as LLVM, so the backend doesn't take as much time to run. But then again, the performance of the outcome really depends on your workload and your use case. But that's something that you can use as a design constraint to work with in your programs to work around that. So you kind of have a complexity and performance budget, and you're trading some complexity away to get you're trading performance away to get the complexity back with Cube. And if you have, for example, like a cryptography algorithm, like you want a really fast AES implementation, it's going to be substantially slower when it's written in Cube. But for really hot paths like that, it's compute-intensive algorithms like AES, you're better off handwriting it in assembly or even taking advantage of native features like x86 has native AES support, which outperforms both Cube and LLVM. And so at that point, it's a moot point.
That actually begs the question now. What about, can you drop down into assembly in Hare or to platform intrinsics, or is that to be added?
Well, Hare does not have a significant level of optimization. It doesn't do much in the way of intrinsics at the language level. mostly because it's designed in a manner which encourages a greater degree of portability, which would be possible if we had first-class support for using intrinsics. But we do have first-class support for mixed language projects, so you can write part of your Hare code or your Hare project in assembly, and the toolchain will handle integrating those for you. And we have the ability to integrate C code as well, and we have good documentation and tooling for supporting the ABI differences and so on. So we kind of meet in the middle, so most of the time, if you're writing Hare code, you're not expected to be working at that level of optimization. You're expected to drop into a lower level or a different language if you have a performance bottleneck which demands that kind of feature.
Yeah, that was really just more of a question from when you mentioned the cryptography code that made me think about that. What about a cross-compilation?
So cross-compilation with Hare is very, very good. Generally speaking, if you are installing Hare from your package manager from your Linux distro, and your Linux distro has followed our packaging guidelines, then you'll have a toolchain already installed where the only thing you have to do to cross-compile is pass a flag which specifies the architecture you want. So you do Hare build -a AR64 instead of x86-64, for example. Although I will say that this depends on the distribution having binutils for your target architecture available and packaged and configured against the Hare toolchain for you. So for an end user using a distro that has done this and followed our recommendations, it's very, very easy, but not every distro has done that, so your experience may vary. And also on our documentation for cross-compiling, we have the easy way and the hard way. And what I just described is the easy way, but we have a note which says, if your Hare program links with C, just skip to the hard way.
So at the beginning, you talked about some theoretical uses of Hare, but can you give us some examples of practical projects that have actually been written in Hare and what makes them different from other languages?
I don't know exactly what everybody is up to in the community, but I can tell you a handful of projects that I've worked on or that I know that people have worked on. There are some projects which are useful and being used already, and there's also many projects which are in the proof of concept stage or developing more of an ecosystem necessary to support them. So, for example, we have a GUI toolkit in development, which is nowhere near usable because it's written in pure Hare and doesn't so much link to as much C stuff, and so we have to build up vector graphics and a Wayland implementation and input processing all from the ground up to get there. And so all of that work is happening, and those are independently useful for different things, but it's not a complete product yet. But there are some complete products. So there's an implementation of the redo build system that somebody has done in Hare, which is like an alternative to make. And there's a few other things like that. As far as my projects are concerned, I have a secret storage manager called Himitsu, which is, I've been using it for like a year. It is mostly production ready, which is like a password manager, but more general. It also stores like SSH keys and things. And then I'm also working on a operating system written in Hare. I have a microkernel and a bunch of drivers and a user space in Hare, which is, it can run ed, the text editor. So I don't know if that's useful for your use case, but it's getting there. So yeah, there's a few different projects being made in a few different domains, but that kind of gives you the idea of like the systems level thing we have going on.
Does it integrate at all with, I think it's libsecret?
No, but I think somebody is looking into that. I think the main blocker for integration with libsecret is I think libsecret is based on dbus, and we don't have a dbus implementation for Hare yet, but we need that for some other stuff, so it's coming.
Okay, this episode is sponsored by Kolide. What do you call an endpoint security product that works perfectly but makes users miserable? A failure. The old approach to endpoint security is to lock down employee devices and roll out changes through forced restarts, but it just doesn't work. IT is miserable because they've got a mountain of support tickets, employees start using personal devices to get their work done, and executives opt out the first time it makes them late for a meeting. You can't have a successful security implementation unless you work with end users. That's where Kolide comes in. Their user-first device trust solution notifies users as soon as it detects an issue on their device and teaches them how to solve it without needing help from IT. That way, untrusted devices are blocked from authenticating, but users don't stay blocked. Kolide is designed for companies with Okta, and it works on macOS, Windows, Linux, and mobile devices. So if you have Okta and you're looking for a device trust solution that respects your team, support the show and go to kolide.com/LinuxDevTime to watch a demo and see how it works. That's kolide.com/LinuxDevTime. Quick bit of admin then. First of all, thank you everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to linuxdevtime.com/support. And remember that for various amounts on Patreon, you can get an advert-free RSS feed of either just this show or all the shows in the Late Night Linux family. And you also get quite a lot of episodes a day or so early. And if you want to get in contact with us, you can email show@linuxdevtime.com.
As I understand it, one of the key goals for Hare is stability. So I wonder if you could talk about what you mean by stability and what that goal is.
Yeah, for sure. Stability is very, very important to Hare in a way that I think really distinguishes us from any other programming language under modern development that I'm aware of, except possibly C, and even then. We have decided that we want to make what we call a 100-year programming language with Hare. The essential pitch of the 100-year programming language is eventually we're going to finish Hare and we're going to release Hare 1.0. And at that point, we're going to freeze the specification and we're not going to make any further language changes. And all of the standard library changes we make from that point onward will be backwards compatible. And so what this means is that on the day Hare 1.0 is released, you will be able to write a Hare program. And in 100 years, that Hare program without changes will still compile and run, assuming it only targeted like the portable subset, it didn't use Linux-specific features or whatever. It will compile and run on a modern system in 100 years. But moreover, if you write a Hare compiler on the day that Hare 1.0 is released, in 100 years' time, that Hare compiler will compile contemporary Hare code.
That's quite a bold claim.
That's the goal. We'll see if it really works out.
Right, okay. A bold goal then.
But we are taking it very seriously, this goal. We have a lot of plans and things that we put into place with this goal in mind, and we think it is achievable.
Presumably making it architecture agnostic is a huge part of that then, because we're not going to have x86 and ARM in 100 years probably, I wouldn't imagine.
Yeah, that's indeed the goal. And, you can, like I said, you can write a Hare program which like intermixes Hare source code with assembly source code. And at that point, your portability guarantees obviously go away. And if you use the Linux-specific /proc file system and expect it to look like Linux /proc when you write your PS implementation, it's not going to be portable to an arbitrary computer in 100 years. But if you use the Hare standard library and you read the portability notices, like if you don't import the runtime and use syscalls directly, we give you a path where you can write a program. And the easy way of writing a Hare program is to do this, where your program will be portable to future implementations of Hare.
So this is like an incredibly ambitious goal. I was wondering, do you have any examples of other projects that have this kind of stability guarantee? Or have you made this up?
There are some which are frozen. I forget the name. It might be Scheme that's frozen the language. I'm not sure. There's a functional programming language where the core language has been frozen for some time now. And we also have languages which are remarkably slow in their development, but still relevant. Like the C programming language is rather slow and is one of our inspirations. I think that part of why C kind of accidentally had 50 years of staying power was because it was slow and conservative and changing. But so far as I'm aware, we're the only language that has set this as an explicit goal to guide our development and our processes.
I must say, it does remind me of the 100-year plan from WordPress that costs $38,000 and they claim that you're going to, have all your legacy, the various generations are going to be still on WordPress in 100 years.
You need to pay up, Joe, if you want your Hare stability.
Yeah.
We took the smarter route than WordPress did of not making a guarantee that relied on us being able to spend money on servers for 100 years.
Rust, while it changes a lot. And nobody is saying that it won't change after 1.0, but people in the Rust community have said that they don't want there to be a Rust 2.0, so they always want there to be strong backwards compatibility guarantees. And one of the ways that they are looking to achieve that is with their addition system, where you can make breaking changes in the standard library at a new edition. However, all compiler versions have to be compatible with all editions. Ergo, a program written under the very first edition, which happens to be, I think it was Rust 2015, will still compile even with a compiler, 50 years in the future, theoretically. Is Hare looking to do something similar with editions? And I know you're not looking to add additional features, but I'm thinking about with like either deprecations or, security things that happen 75 years from now.
Yeah, I think that's an interesting way of doing it for Rust, and I can see why it suits their goals. But Hare is going a bit further. So Hare is also going to do forwards compatibility, which is something that Rust very much lacks. So you will see that Rust has great backwards compatibility, but the forwards compatibility is quite poor. Obviously, if you use new features from a new compiler, that's not going to work. But more importantly, Rust culture evolves. So the idea of what is idiomatic Rust code changes in a way which is not backwards compatible. So like you'll see, the various async IO approaches, they all still work, but there will be one which is kind of accepted as the way to do that. And then everything which doesn't do that is no longer idiomatic. And so that's kind of a bit of a problem, and it creates like a maintenance churn, or at least it's a good way of raising tech debt. And we want to avoid that with our strategy. But we're also doing something for the standard library with that respect, which is not exactly like the additions thing, but we have some ideas which are similar. So we have a relatively fixed scope for what needs to be in the standard library, and it might actually shrink before we define 1.0. And we have specific stability guarantees. So we'll guarantee the language, so its grammar and its semantics is not going to change, but we have different guarantees with the standard library. So we define a set of backwards compatible changes that we are permitted to make in the future. And then we also have a very narrow definition of backwards incompatible changes we're allowed to make. And that's essentially just limited to the cryptography implementation. So the standard library has crypto algorithms implemented, and we have said we are prepared to make breaking changes indefinitely to remove obsolete cryptography algorithms. And that's one place where this guarantee is not present. But kind of like the Rust additions thing, when we remove an obsolete algorithm, we've already done this with MD5, which was obsolete even before we implemented it, but just as a test case. When we remove an algorithm from the standard library, it moves into an archive state, and you can actually re-import it, and it will still work, and all of the code that was based on it will still compile. It just won't be in the standard library or the standard distribution. You have to go get it yourself. And because the language is not changing, and the standard library from the rest of the standard library is backwards compatible, the same code will work forever, so you don't actually necessarily lose it. It's just we're not going to guarantee that we'll always maintain that code.
Speaking of dependencies in the standard library, what is Hare's approach to that? I know Go, for example, has a huge standard library, but other programming languages don't, and they rely more on external libraries.
We have a larger scope than C and a smaller scope than Go. But a lot of our standard library design is inspired by Go, as a matter of fact. But we're trying to implement essentially the subset of the language use cases, which basically everybody is going to need. So, for example, that means that we have implementation of regex, because it's rather common to have regular expressions. It's needed for a few other things, but we don't have HTTP in the standard library, whereas Go does. And this is also a matter of opinion. So there's some more opinions that go into an HTTP implementation. You have Go has some opinions with how to do routing and things like this in their HTTP server implementation, which has led to a proliferation of alternative approaches. We don't want to do that. If we're going to have a feature in the standard library, it should be the definitive implementation of that feature for Hare. And if there's some room for that to be different, it doesn't really belong there. And we also kind of, as a rough, loose metric, saying if a feature is necessary to implement Unix, it should probably go in there. So we have, for example, function match and glob are also in the standard library for that reason. And we also have a handful of things for we have a Unix module, which has different portability guarantees. Obviously, it only works on Unix systems, but it has things like get UID and set UID, things like that go in there. So this is kind of the scope that we're aiming at.
You kind of touched on it there for just a second. But I've seen also that you don't want to support closed platforms, i.e. Windows or Mac OS. Is that something you just don't want to put your time and energy into, but you're okay if someone else contributes those things, or you'd prefer that those types of closed systems stay out of Hare altogether?
What I would prefer is one thing, and what we've decided on as a project is a different thing. And so I would not prefer to have support for any non-free operating systems. And that's also a policy of the Hare project. But that's more of a policy of what we want upstream in Hare. And so we don't want to be responsible for implementations for non-free operating systems. I can't tell you how often I've been working on Hare and I need to understand something, so I go read the Linux source code or the FreeBSD source code or the OpenBSD source code. I think I've read that stuff several times a week minimum during an average work week. Like, we look at the code so that we can understand it and we can build stuff on top of it that works and is also understood. And we can't do that with non-free operating systems. And I'm not really interested in reverse engineering Windows to do the same thing. And so it doesn't make sense for us to try and make the kinds of guarantees and the things that we want to provide. The goals for the project are incompatible with a non-free operating system. We want to be able to take responsibility for the operation of the system from top to bottom, and we have to understand it from top to bottom. We can't just place Hare on top and say, we promise that we haven't missed anything in Windows about how it works, and we can't do that. And so it's culturally incompatible with our technical goals and is culturally incompatible with our political goals. And so we don't want that upstream. But at the same time, we standardized Hare for a reason. We have a specification, and the code is open source. And so we are by no means opposed to a third party implementing the specification in their own compiler and their own standard library fork, or even a new one, targeting whatever platform they want. And as a matter of fact, this has already happened. There is a third party that maintains macOS support, and good for them. But it's just not something that we're doing upstream.
Well, this kind of leads me on to a question about community and governance. It sounds like you spent an awfully long time thinking about the technical aspects of Hare, but have you spent an equal amount of time thinking about how to make sure that the community around it stays positive and a place that people actually want to hang out in?
Oh, very much so. We've put a lot of attention into that. In fact, I started the project and it was initially just me, and then it grew slowly with a few other people getting involved, and then grew to the scale it is today, where there's about 100 contributors. And the governance has changed. So initially it was just, send me a patch, it looks good, I'll take it. Let's make an IRC channel so we could talk, very informal as these things usually go. But then we've applied processes or cultural norms as they've been necessary. And this is something that we pay attention to. And so when there's a need to make a change, then we make the change. We don't just kind of hope for the best. And this puts together a community where I think that people are empowered to participate in meaningful ways, and also where it's healthy and productive and you have fun doing it. There's a lot of people who have formed friendships. Maybe this is kind of a silly metric to talk about, but I kind of have a suspicion that the average contributor to new friendship pipeline is denser in Hare than in many other projects. It's a fun place to be, and it's sociable and respectful and professional, but also fun. And so we have introduced a code of conduct, and then we have my role being scaled back, where I'm a BDFL kind of, but with the mandate of the community, where it's basically just a tool for somebody has to be the fiduciary agent of the project, and somebody has to resolve disputes on division. The community can ask me to do those things, and I'm the person they ask. But other than that, there's 10 maintainers, and nobody is more so than anybody else. And it's not like a privilege that you get to be a maintainer. It's more like a role that you have because you're good at that kind of stuff, and we try to empower people to do the things they're good at. And it all works, I think. I think we have a very healthy and scalable community in this respect.
So this is a slightly off topic from Hare question, but Drew, you're involved in so many projects. Just looking at all the different things that you've released between SourceHut, and I've seen other things like Sway and WL Roots, and I might mispronounce this, but the email client AERC. There's so many cool projects that you're involved in that you've either started or maintain. How do you find time to do all of this, including Hare, and how do you juggle all of these projects?
Well, it's very kind of you to mention that. I am a kind of prolific, but in a sense, I'm not. I think the secret is that I'm pretty good at getting people to help me. And so I've written a blog post called It Takes a Village, which you can look up if you like, where I just one day I listed all of the people who have contributed to the projects I started. And there's more than 1,000 names. I could never build all of that stuff on my own. I'm basically just a guy who tries things, and I think a lot of people struggle with that. So if I have an idea, I'll try to do it. I'll try to ignore the imposter syndrome and put all of the doubts in the back of my mind. I'll just be like, why don't we sit down and try to code this? And then I'll publish the source code early, and I'll talk to my friends who I think will be smart and knowledgeable about the domain that I'm experimenting with, and maybe they'll contribute a couple of patches. And by publishing early and being good at convincing people to help and fostering collaboration, that's how all of this stuff gets done. It's not because I'm some genius supercoder who doesn't have a life. Like, I have a life. I just get people to help me.
It sounds like Hare is at a really exciting stage. Like it's being rewritten in Hare at this point, or it's about to be. Is that right? Is now a good time to get involved with Hare development?
Now is a great time to get involved. It's not exactly that it's being rewritten in Hare right now. Like, that's just one of our long-term goals, okay. And we do some stuff towards that end. Like, we have some upcoming compiler work that we all have in the back of our heads that, like, oh, once we finish this compiler work, we'll be able to do the next 5 things on the to-do list for the Bootstrap. But that's, like, nice to have. You know, we're not in a rush to the finish line where we have a fully bootstrapped complete compiler and a complete specification. We're just going to get there when we get there. But there's still lots and lots of exciting stuff to work on. We're working on new protocol implementations. We're working on graphics and graphics formats. We're working on GUIs. We're working on networking, cryptography. TLS is being implemented from scratch in Hare. And then there's the compiler, the standard library, all kinds of fun stuff to work on. It's definitely a great time to check it out if the pitch appeals to you.
Well, it's been absolutely great talking to you, Drew, but we'd better wrap it up. We'll put some links in the show notes to the blog post and the various resources. If you want to send me anything, I'll make sure I include it. But we'd better get out of here. We'll be back in a couple of weeks. But until then, I've been Joe.
I've been Kevin.
I've been Andy.
I've been Amalith.
And I've been Drew.
See you later.